Hey everybody, this is Alex Merced, developer advocate here at Dremio, and welcome to another episode of Gnarly Data Waves. And in this episode, we'll be talking about an introduction to Dremio Arctic, catalog versioning, and iceberg table optimization. An exciting topic, which I'm sure you're going to enjoy. But before we get in there, I want to remind you that you can test drive Dremio by heading over to dremio.com and clicking that test drive button where you can test the Dremio Lakehouse platform at no cost and no obligation. So you can see what the big deal about the data lakehouse is and what can be done directly from your data lake when using the Dremio platform. Also, make sure to pick up an early copy of Apache Iceberg, the definitive guide. So right now, the early release copy has about like 180 pages worth of Iceberg content. The final manuscript will be 300 plus pages, released early next year. So go check it out. It's free. Get an early copy. Scan that QR code. And Dremio will be at many different events, such as Big Data and AI Paris, Big Data London, coalesced by DBT, and me and Dipankar, the developer advocates here at Dremio, will be at Data Day, Texas in January doing an Apache Iceberg Ask Me Anything. So make sure to be there. It's going to be a good time. I was at Data Day, Texas last year, and it was a delightful time. So make sure not to miss it. Okay, but with no further ado, let's get on to our feature presentation, Introduction to Dremio Arctic, Catalog Versioning and Iceberg Tail Optimization with Jeremiah Morrow, Product Marketing Director here at Dremio with Iceberg and Dremio Arctic. Okay, with no further ado, Jeremiah, the stage is yours.
Thanks, Alex. Hi, everyone. My name is Jeremiah Morrow, and I'm responsible for product marketing here at Dremio. And these days, I'm mainly focused on Apache Iceberg, as well as our Lakehouse management service, Dremio Arctic. And today's Gnarly Data Waves episode is all about Dremio Arctic. Here's a quick agenda for the next 30 minutes or so. First, to review, I'm going to talk about the rise of data lakes and how we sort of got to the architectural inefficiencies that we've gotten to today. Then I'll talk about what's needed to bring us from data lakes to a data lakehouse. Spoiler, table formats are a key part of that story, and we love Iceberg here, so I'm going to talk a little bit about Apache Iceberg. And then I'll talk about how you can enhance and expand that Iceberg experience with Dremio Arctic, including automatic optimization for tables and catalog versioning with dataascode. And then I will briefly show you some of those capabilities in a quick Arctic demo. And then afterwards, we should have plenty of time for Q&A, so get your questions ready, and whenever you like, you can ask your questions, and we will address them at the end of the presentation. So data lakes and data warehouses, how did we get here? It started decades ago when we were all using a data warehouse, an EDW, and it was really good at what it was designed for. It could store, organize, and analyze primarily structured data from business systems sitting alongside it, housed in a data center. And it could provide reporting on that data within a reasonable amount of time. But then we started collecting more data and more data types, including semi-structured and unstructured data. And data was coming in from a lot of different sources, mobile devices, social media, Internet of Things. And a lot of those sources were outside of the data center. And the data warehouse was built for a time and place when that scale of data was not there. And it couldn't keep up with data growth, and it also couldn't meet much more aggressive SLAs for performance, things near real time, for example. So we built data lakes, first with Hadoop on premises, and then as cloud vendors grew, we used object storage. And data lakes were also really good at what they were designed to do. They were really good as cheap and efficient storage for a large volume and variety of data types. And data scientists loved it for small scale data science projects with small teams of data scientists. But the data lake never really replaced the data warehouse for enterprise BI and reporting. It struggled especially with concurrency, and it was missing support for ACID transactions. So the data warehouse lived on. And so this is what we see in probably 99% of the organizations we talk to today, enterprise organizations. This is what I call a cooperative data architecture. So you'll have one or many data warehouses. sitting alongside one or many data lakes, both of which are doing pretty much the same thing they've always done. Data warehouses for BI and reporting, and data lakes for data science. And so if a data consumer needs an important source of data from the data lake for a dashboard or a report, the data team needs to move that data over via some ELT or ETL process to make that data available for data consumers. That's fine at a small scale, but over time, this architecture takes a lot of work and effort to maintain, especially as more of the data that we need for BI and reporting lands first in the data lake. And those ETL and ELT processes begin to proliferate, and every new pipeline becomes another asset that the data team needs to manage and maintain in order to deliver on data access. So most data teams have a goal of presenting a unified view of all of the data for end users. And there's a really fun philosophical conflict right now in the market about which of these architectures is ultimately the one we should be consolidating on. Is it the data warehouse, or is it this new concept called the data lakehouse, which combines the flexibility and scalability of data lake storage with the analytics, particularly the BI and reporting capabilities, as well as data management and data governance that you get in a data warehouse? And I think based on the fact that data lake storage is increasingly becoming the de facto landing spot for more and more of our data, if both architectures were completely equal in terms of capabilities, most of us would probably choose the data lakehouse. So the first attempt at giving data consumers direct access to the data lake was to put a query engine on top of data lake storage. And that idea has been around for a really long time at this point, relatively speaking. And it does serve a purpose, and it works in some cases. We have obviously a lot of Dremio customers who are happy analyzing data in place using our arrow-based query engine and the semantic layer to join and query data wherever it lives, including data lake storage on premises and in the cloud. But to build a lake house, we need to add something new. We need a layer in between the data lake and data storage uh, and the engines, the execution engines. We need to enable all of the things we can do in the warehouse, including governance, write support, storage optimization. We need to accelerate query performance to give customers the BI performance at scale that they need. And we need to make all of that very easy. So we've added a few layers to the stack. And these are efforts to deliver some of that management and governance capabilities that you find in a data warehouse. So the first attempt at organizing the lakehouse were file formats. And file formats were proven to improve performance and also compress data for storage optimization. And a lot of companies have seen the benefits of standardizing on a file format like Apache Parquet, for example. So table formats are sort of the natural evolution of file formats, and they build on a lot of those optimizations to make data even easier to manage, like a company would manage a data warehouse. Once you've adopted a table format, the final piece of that puzzle is a lakehouse catalog that makes data management really easy and efficient, that provides the security and governance capabilities that enterprise organizations need for their data, and that makes it very easy for all of your end users to access a consistent and high quality view of your data. And for us, that's Dremio Arctic. So these are the steps that it takes to build a lakehouse, to go from data lake to data lakehouse, adding all of these in the red. Most companies are at this point are using file formats. They've seen the advantages of file formats. Parquet does a lot to compress the data to deliver higher performance than like CSV, for example. And some of those customers are using some sort of file format in their data lake. So let's talk about table formats, and specifically, let's talk about Apache Iceberg because it has a lot of cool features for data management that we love here at Dremio. First, it's open. It's an open table format, which is important for a couple of reasons. First, proprietary technology is part of the reason we are where we are in terms of that graph that I showed you earlier with the architectural inefficiencies. Um, I've talked to a lot of customers over the last 5 years or so who say and know that they need to get off of their legacy data warehouse. It's slow, it's expensive to maintain. In order to achieve the performance they're looking for, they have to duplicate data in the form of BI cubes and extracts. And all of those are an additional layer of management. It was never designed for the scale of data that we have today. The problem is migrating off of those platforms takes a lot of work and a lot of time. And so keeping your data in open formats like Apache Iceberg ensures that you don't have that difficulty the next time there's an innovative data tool that you want to leverage. By keeping data in the data lake in an open format, you will always be able to access it and it will be available to you no matter what tools come down the road. Second, Dremio certainly believes, and I definitely believe, in a multi-engine future. In the future, one execution engine doesn't do every data job well. And so you and your organization should have access to the most efficient and the best tool for every analytic workload. So Iceberg is an open table format. It's got the most contributors of any table format on the market today. It's got the support of a lot of technology companies, meaning that by choosing Iceberg, you can be assured that you're going to find support within the ecosystem, that your tools are going to work with Iceberg now and in the future. Iceberg was built to solve a lot of the challenges with table formats like Hive, especially for large tables. So Iceberg enables easy table optimization with features like garbage collection and compaction, which solves some common challenges for enterprise data lakes. It enables consistency with ACID transactions, and it ensures high performance queries even at massive scale. So if you're undecided on a table format for your data lake, take a serious look at Apache Iceberg and definitely talk to our developer advocate team. Alex and Dipankar are regulars on Gnarly Data Waves. They put some great content out on social media, LinkedIn. Very good source of information. They've written and produced a ton of really valuable stuff around Iceberg. But for Dremio, Iceberg is just the beginning. We wanted to make Iceberg even easier for companies to use by automating a lot of those optimizations that Iceberg provides, so data teams don't need to think about them. They just work. And we wanted to provide the tools that enterprise data teams absolutely need to adopt a data lakehouse. And for a lot of our customers, that's security and governance. And finally, we wanted to make it easier and more cost efficient than ever to provide a consistent and accurate view of your data for every data consumer, continuing the Dremio tradition of not needing to manage and maintain multiple copies of data. And so Dremio Arctic uses data as code for that. So that's what we built with Dremio Arctic. It is a lakehouse management system that makes it really easy to manage your Iceberg data lake, and it features data optimization, data as code, and enterprise-grade security and governance. And now we can go through a few of those features. First, Arctic is a modern lakehouse catalog. It's Iceberg native, so a lot of features are based on Iceberg functionality, and we're adding to that with some automation. Arctic is based on projectnessie, which is built into the Iceberg project. Dremio is accessible by multiple execution engines. You can use Dremio for interactive BI and dashboards, which it's excellent at. And you can also use other execution engines for different analytic workloads. One of the key use cases for Dremio is enabling a data mesh, and Arctic definitely enables that architecture with the ability to manage multiple catalogs in complete isolation. So give your domain owners federated ownership of their data, and enable them to share data across the organization very easily. And of course, we feature access control and integration with user groups and directories with additional RBAC features coming soon. So from an optimization standpoint, we took some of the features in Iceberg and added the ability to essentially set it and forget it. Today, a lot of this is schedule based. So you set it on a schedule, it does it in the background without you having to manage it. And full automation is coming down the road. The first is table optimization, which is based on Iceberg's compaction feature. So it solves a really common problem we hear within enterprises for their data lakes, where because of streaming or micro batching, you're ingesting a bunch of small files that need to be rewritten into larger files for performance. For a lot of companies, this is a very manual, incredibly labor intensive and tedious task that the data team just has to do in order to deliver analytics on streaming and micro batch data. And with Arctic, you can just schedule compaction jobs to take place at regular intervals and then just forget about it. It runs in the background. The second is table cleanup. And so that's Iceberg's vacuum function. And so vacuum removes unused files to optimize storage. Again, just like with compaction, this is a manual task that Arctic can do regular intervals. So the data team just doesn't have to worry about it. And together, these capabilities ensure high performance on your Iceberg tables and also a lower storage cost as well. The next feature that I want to talk about is my favorite, and it is data as code. So at its core, data as code is the practice of applying software development principles to data management and governance. And to set the stage, essentially, here's what our customers tell us they want. They want every data consumer to have access to a consistent, accurate, high quality view of their data. They want to make it very easy to make changes to the data in isolation without impacting other users. And all of that using traditional tools and traditional data management techniques is incredibly difficult. Often it means having to stand up, manage, and maintain multiple environments for dev, test, and production. And on the other hand, from a data consumer perspective, data scientists often want access to production quality data, but in a safe way that enables them to do what they want without impacting other users as well. And so they require their own environment. All of these multiple environments are brand new copies of the data. They're new data pipelines, and all of them need to be managed and maintained by the data team at the same time. So data as code uses essentially get-like features, branches, tags, and commits to enable very easy version control and delivery of multiple consistent and accurate views of production data without having to build multiple environments. It's a zero-copy architecture. It uses metadata pointers, a feature called snapshots, in order to show the state of the data lake at a certain point in time. And so what you can see here is multiple branches of the main branch. Again, zero copy clones. So in this example, I have my main branch of the data, and that's my production branch where my end users are using that data for things like dashboards and reports. If I want to make changes to that data, I can create a separate branch. So in this example, I have an ETL workflow. So I'm adding new data in, and then I can check it for quality before I merge it into the main branch. Every step of this process is visible through a commit history. I can use tags to call out specific commits. That's those green bubbles there. And all of the work is done, again, no copies, and my users don't see any changes to the data until I merge the ETL branch with the main branch. On the lower branch, the data science branch, if I want my data scientists to have access to production data, I can create a data science branch, and in just a few seconds, they have access to production data that they can do whatever they want with in complete isolation from my production users. And tags and commits give data scientists some great tools for collaboration and also for model reproducibility. So overall, data as code gives data teams the ability to work on data in isolation while delivering a high quality version of that data to their end users. It delivers very easy version control and another level of governance where every single change to the data is tracked. And recovering from mistakes takes just a click of a button, and you can roll back to a previous state of the branch. I wanted to share a use case, and I mentioned data mesh. So I want to share an example workflow within that context. So data as code makes a lot of sense for managing data products because now we can treat them like software applications. And if you talk to a software development team today, developers would never ship a product without thorough testing, without quality assurance, and some form of CI/CD. And so, why, as a domain owner, would I ship a data product without the same level of version control and ease of delivery and consistency? So in this graphic, we have a sample domain level catalog. We have a marketing data product that shows web traffic. We, the data team, need to make regular updates to the data product as web traffic obviously changes over time. And multiple users within marketing and other departments might be using the web traffic within their dashboards. So we need to make these updates in isolation without impacting their dashboards. With data as code, our data product that we are presenting to our end users is the main or production branch. And we use an ETL branch to bring new data in. We can do all of our testing. We can even run a dashboard against the branch to make sure everything is working once we've added the new data, and the new data is represented in the results. After those quality checks, we can merge to main, and our production customers will see the new view of the data after the merge. Super cool, right? So that's Dremio Arctic in a nutshell. Easily manage your iceberg tables with automatic optimization, and manage your data like software code to deliver a consistent and accurate view of the data to all of your data consumers in a no-copy architecture. Now let's look at Dremio Arctic in a quick demo to see some of these capabilities in action.
Hey everybody, this is Alex Merced, developer advocate here at Dremio, with a quick demonstration of just sort of like the new Dremio Cloud UI and the new integration of Dremio Arctic as the default catalog in Sonar. Okay, so basically, again, the Dremio Cloud platform has two different types of projects. There are Sonar projects, which are the query engine, which is what I'm on the screen that I'm on right now, and then there's Arctic catalogs. Okay, so now when you create a Sonar project, every Sonar project is going to have a default catalog. So in this case, my default catalog is located over here. Okay, and that's going to be sort of my main place for organizing in this Sonar project. But I can create other Arctic catalogs, which then show up like other sources, like be connecting to object storage or databases. Okay, and the cool thing about this is that it feels the same features that the Spaces feature did in the past, where I can now break down this space or this catalog into different sections. So in this case, if I were doing like a data mesh, I could break it up into different folders like accounting, marketing, sales, which can then be governed and controlled. But you get the added benefit that any views I create and any Apache Iceberg tables that I create within these within the catalog are now versioned. Every time you create a folder, that's a commit. Anytime you create or alter a table in an Apache Iceberg table in the catalog, that is a commit. Every time you create or save a view, that is a commit in the catalog. So let's just show you some transactions that kind of illustrate some of that. Okay, so I'm going to head over to the SQL editor in my Sonar project. And what I'm going to want to do is I'm going to want to create, let's say, a new table. Okay, now I could do this. I could say create table. And what I'm going to do is I'm going to do this in my demos folder. So actually, before we do this, again, I can create a new folder pretty easily. And so if I go to demos, okay, what I'm going to do is I'm going to make a folder for today. So I'm going to click here, add, and I'm going to add a new folder. Okay, and now today is September 8th. So we'll do this for sep8. Okay, cool. And now I've just created that folder. And again, the creation of that folder is actually a commit. So if I head over to here to Arctic catalogs, I can go browse my different Arctic catalogs. This was in my demos catalog. Okay, and then I can see here in commits, I can see my commit history and I can see, hey, we created that folder. And the cool thing is when you have multiple users in Dremio, I can see which user made the transaction. I get the transaction ID, which I can use to do like rollbacks for auditing purposes or to time travel. I can then also, again, see exactly what was done there. So I know what was done and who did it. Okay, and I can see when they did it. Okay, in this case, 15 seconds ago. Okay, so I get this nice auditable view for me to understand what's kind of going on in any particular Arctic catalog. Okay, and then again, I can also audit my branches while I'm here, any tags within that catalog. Okay, and then browse the data in that catalog. But let me go back to that Sonar project now that we created that folder. So go back to my Sonar project. I'm going to go back to my SQL editor, and I'm going to create a table. Create table. This is going to be in my demos catalog, and it's going to be in that September 8th folder, which is sep8. And we're going to call this table, names. Something really simple. Okay, and it's just going to have one field, name, which is going to be a varchar. Okay. And we'll do a couple transactions right off the bat, and I'm going to just insert a few records. Insert into demos.september8th .names values, and we'll insert my name. Okay, and cool thing, I can run multiple transactions in one sort of Dremio session, in one run of the query runner. So I'm going to hit run, and that's going to begin running these queries. So I can then see the progress of all these queries that I've lined up right here. Okay, so it created the table, and now it's going to insert the records. Okay, and then once these are done, we'll be able to inspect the jobs. Okay, so now I can click here on query 1 to see that the table was created successfully. I can click here on query 2 to see one record was inserted. Okay, now what if I wanted to insert more records, but it might get a little tedious to keep typing in demos.september8th.names. Now, cool thing you can do, so let's insert another record. What if I just want to use the table name? So I'm going to say insert into names, values, okay, Jeremiah Morrow. Okay. Now, how do I type this? How does it know that I specifically want to go inside demos inside that September 8th folder? What we can do is that there's this context section right here. Okay, and in this case, what I can do is I can set the context specifically into my demos catalog. Okay, and into that September 8th folder. And that sets the context of the session. So now going forward, when I run this query, it's running that from that context. So it's always going to assume that part of the namespace going forward. And again, I can even do that to change branches. So as we'll see here later on, I'll be able to create multiple branches, and I can even switch that branch context here if I wanted to for that run of the SQL editor. Okay, but I can just run that query, insert another name into the table. Okay, and we'll get that done. Okay, so that's inserted. And now what we'll do is we'll just query the table, select star from names, because again, we're still in the same context, so I don't have to type out the whole namespace. Okay. And cool. Okay, there's my two records. So we can see, and then again, that's querying from the main branch. Now let's say we wanted to add some records. Okay, what I can do is I can create a branch, and the cool thing is that Arctic is backed by an open source project called Nessie. So everything that I'm doing here, you can do in any tool. So you could be doing this in Spark, you could be doing this in Flink, you could be doing this in any tool that supports an SE catalog in the sense of being able to utilize different branches. So what I'm going to do is I'm going to create a branch and then insert more records from the branch. So that way, what we're doing is we're going to isolate isolate those records. So that way they're not necessarily visible by our mainline production. Okay, so then what I can do here is first we'll create a branch. So we'll say create branch. Okay, and we'll just call it September 8th. Okay, and then I have to say which catalog it is. So this is going to be in the demos catalog. Okay, create branch September 8th in demos. Then we're going to want to switch to that branch so that way every query going forward is in the context of that branch. So use branch September 8th in demos. Okay, and then I can go do my insert. So insert into, and just to be 100% sure, I'm going to type out the full namespace. So we'll say demos.september 8th names, and then what I want to insert here is we'll insert Dipankar Mazumdar and Jason Hughes. Okay, so there's going to be our query. We'll run that. Okay, so what it's going to do is first it's going to create the branch, and now that catalog now has a new branch. It's collecting all the commits and transactions that occur in that catalog from that branch. Okay, now I've switched over that branch and I've done the insert. So now I've inserted these records. Now just to prove to you that I've made these changes solely on the branch, here's what we're going to do. So first off, we're going to query from names, select star from names. Okay, and again, since our context is switched set to main, again, this is always going to be where the SQL runner starts. I can change the context using those use commands, but this is always the starting place. So it's starting from main. So then what I'll do is I'll switch over to use branch September 8th in demos, and then we'll try to do that again. Select star from names. And again, just to be 100% sure, I'm just going to do the whole full namespace. So demos.september 8th dot names, and I'm going to just do that over here. Okay, so again, this query should be coming from the main branch. Then we're switching branches, and then we're going to query it from that branch that we created. Okay, so it's going to run those queries. Okay, and now it's querying the branch. Cool. Now if I take a look at the first query, see it's only Jeremiah and Alex were there because those were the transactions we did when we were still on the main branch. But then after switching branches, which again, this basically says now we're switched over to the September 8th branch. Okay, now you see Jason Dipankar added. Okay, so you notice that data is now isolated there. So this has several different implications. Again, that can be used for isolating ingestion. Okay, because of that, I can do multiple transactions in that branch before ever merging and publishing those transactions, enabling multi-table transactions. Or on occasion, I might just create a branch just to create an environment for somebody else to play with. So they can go do whatever they want that branch, experiment from that branch, add, subtract, insert, delete records, knowing that any changes they make from that branch will not affect what's visible to the mainline production branch, which, you know, all your front lines analysts are running analytics on. So you enable all these possibilities, and all of it is without doing duplications of the data or having to create sort of an isolated duplicate of the data to do your changes on and swap it out. None of that. It's just all zero copy. Okay, so that's all very well and good. Okay, but not only do you get that, okay, so that's just sort of showing you off the power of Nessie. And again, I could go, create a branch and then, have Spark ingest data into the branch. I'd be able to see the data and work with the data from that branch here and then publish it when I feel like it's ready. All sorts of different possibilities. But other things you can do with, let's leave. If I go to my Arctic project, I go to demos. Okay, what I can do is I can go to like any particular table. So here's September 8th. Okay, here's the names table that we just created. I can click over here and I can set up automatic table optimization. Okay, so basically what you would do is you would go to your project settings. So first thing I'd have to do is just set up my engine for this particular catalog. So you can see here, right here where it says configuration. I'd click here. Okay, and this would allow us to configure an engine for optimization purposes using your AWS credentials. So I would just select the cloud that I already have set up. Okay, and then I can say, okay, hey, I want to, let's say small engine. Here's where any data gets written, and provide the AWS access key and all that stuff. And basically, what it'll do is it'll use that engine anytime we want to optimize our table. And again, it knows when to optimize tables because, again, I can go back here, choose any particular table, and then from here, I can set a schedule and say, okay, optimize this table. So things like compaction, you don't have to think about. It will run that compaction periodically on the schedule that you set. So you don't have to worry about like the small files problem becoming too much of a problem because you just haven't thought about maintenance. It's happening behind the scenes. You're getting that isolation, and it's now all really well integrated into the Dremio UI. Okay, so it makes it really easy. But again, it's not exclusive to Dremio to being able to use that Arctic catalog. That Arctic catalog can be connected to from Spark, from Flink, pretty easily. Okay, if you want to see some examples of that, there's several tutorials I've done on Nessie showing how to connect Nessie catalogs to things like Flink and Spark over there on the Dremio blog, which essentially would be the same if you were using Arctic. You would just basically you would just get your token from Dremio for the authentication purposes, but otherwise it would be sort of the same process because again, under the hood, it's still a Nessie catalog that's providing the catalog functionality. It's enabling that branching and that merging and so forth. So hopefully you guys enjoyed this. Again, my name is Alex Merced, developer advocate here at Dremio. I'll see you all around. Again, make sure to head over to dremio.com/blog to learn more, and I'll see you all around.
So that was a quick demonstration of the capabilities of Dremio Arctic and specifically data as code in action. Another thing that we have done, if you're ready to give Dremio Arctic a try, is that Dremio Arctic is now the default catalog in Dremio Cloud. So every single new project in Dremio Cloud will get a Dremio Arctic catalog. So you get our semantic layer capabilities, which are already very cool for joining and sharing of data, data views. And you can expand on the semantic layer with, again, automatic optimization for your iceberg tables, as well as catalog versioning with data as code. And we have multiple tutorials if you want to start to get up and running and try out data as code for yourself. So check out Dremio Cloud for free at www.dremio.com/get started. And if you have any questions about Arctic or how to use any of these capabilities, feel free to reach out to myself or the developer advocate team. We're all very happy to help you get up and running. And that concludes the formal presentation for today. Happy to start answering any questions that you may have from the audience.
Hey everybody, welcome back. So if you have any questions, do put them in the Q&A box so that way we can get to those questions and help you answer any questions you have about Dremio Arctic, Nessie, and catalog versioning. But our first question we have, can you explain the concept behind data as code? Jeremiah, go for it.
Sure. Yeah, so the concept behind data as code is the idea that software development was really transformed by GitHub. And the way that we deliver software code now with easy versioning, easy governance, collaboration, all of the things that GitHub gave software developers is now best practice. And so why not introduce those concepts to managing and delivering data? And so that is the basic idea behind data as code. Treat it exactly like software developers have treated software development and software code. And the other idea behind it is this idea of zero copy cloning. So your data literally exists as code in a branch. You're not managing and maintaining multiple environments of the exact same copy of data. You're giving everybody a clean version of that production data to do whatever they need to do with.
So our next question is, can we write functions or procedures or packages? So let me take that one. Okay, so when you're saying like if you want to write SQL functions, that's going to be the actual specific SQL you use would be specific to the engine you're using. So in this case, Dremio does support Scalar and tabular UDFs. So you'd be able to use those UDFs and actually save those views based on those UDFs, or save tables that were affected by those UDFs into your catalog. Because the catalog itself isn't tracking necessarily like the SQL or Python you're using. So if you're talking about like custom Python functions, same deal. What Nessie is collecting is essentially, the way you want to think about it is that everything that Nessie tracks is referred to as a key. So essentially like a name. And then attached to each name, there's like a little blob of metadata. And for Iceberg table specifically, that little blob of metadata is just saying, okay, here is where the actual Iceberg metadata is located. So somewhere on your S3 or your Azure blob storage or your Hadoop storage, it's just pointing to where that metadata is. And then that metadata is just pointing to a bunch of Parquet files. So basically the actual, how you run those SQL operations will be engine specific, not necessarily Nessie or Iceberg specific. So in that case, yes, if you're using Dremio, you can write your own SQL functions. If you're using Python libraries, so like let's say you're using PySpark and you want to write custom libraries for working with PySpark, you can do so, and use that with your Arctic catalog, because the Arctic catalog is just merely the interface which that engine will be able to discover your Iceberg tables. Next question, does Iceberg solve the issues associated with Hive, especially asset transactions? Is any other shortcoming of Iceberg we need to be aware of, or any specific use case? Mind if I take that one too?
Go for it.
Okay, cool. Just because I got a lot to say about this one. Okay, so when it comes to the shortcomings of Hive, yes. Okay, so basically, we think about what those shortcomings are. Okay, one is asset transactions. So Apache Iceberg and pretty much all the table formats solve this problem. What they all do is they practice what's called snapshot isolation. So in that case, with Hive, you didn't have individual snapshots. You just basically had the Hive metastore telling you, hey, these are the folders where the table is, and whatever files are in those folders are your table. So you couldn't really see the past history of the table. You can only see what are in those folders at that time. All modern table formats, what they do is they capture the files that are part of the table at any particular time. The mechanism is different. I like the reusability and modularity of Iceberg's approach, where it creates these manifests, these lists of files that can then be included in multiple snapshots. But essentially, each snapshot's tracked, and then which list of files are included in that snapshot are all tracked in the metadata. So I can go back and see those previous snapshots. So you have that problem solved. Now, when it comes to asset transactions, because you have this like linear sort of lineage of snapshots, what happens at the beginning of the transaction, every snapshot has an ID. So what's going to happen is that the next snapshot, so let's say we have a linear numbering, like 1, 2, 3, 4. So if currently the snapshot is 4, and I'm about to write a new transaction, the transaction at the beginning would predict, well, when I'm done, I should be writing snapshot 5. But then what happens is that what if somebody else decides to write to that table at the same time? They're going to project that they should be snapshot 5 as well. So you now have 2 writes predicting snapshot 5. One of them is going to finish first. So when the first one finishes, it commits, it's snapshot 5, it's happy. But the second transaction, when it gets done, before it actually commits, it's going to check to say, hey, am I still going to be snapshot 5? And it's going to wait, no, there is already a snapshot 5. So that's how it knows, oh, I can't commit this transaction. It will then reattempt it. It won't necessarily rewrite all the files, but it'll go back, take a look at the current snapshot and make sure that it can do its transaction with the new history, and then project 6 and then write commit 6. So you don't have this, this is referred to as optimistic concurrency control. So everyone writes as if they're going to commit, but then you double check at the beginning and the end to make sure that there always is consistency in those writes. So in that case, you have asset transactions solved, and a slew of other problems with Hive that are solved. Now, as far as challenges that there are with Iceberg today, they come in 2 sort of flavors. And for the most part, Nessie solves these problems. So that's Dremio Arctic solves these problems, at least one of them. The first problem is multi-table transactions. Right now, just in pure Iceberg, you cannot do multi-table transactions. Okay, so you can only do one transaction at a time on one table at a time, because the specification is based on a table. Now, the Nessie catalog, on the other hand, because you're capturing commits at the catalog level, you can now isolate transactions at the catalog level, which means you can do transactions across multiple catalogs in an isolated manner and publish them simultaneously. So Nessie does address that specific Iceberg shortcoming. They are trying to come up with an Iceberg specific solution to it, but it still doesn't do everything that Nessie does for you. And yeah, and then the other thing that's currently being fixed as well is that the way Iceberg tracks the individual files in your table is using absolute paths. So this does create a challenge when you're trying to, like, let's say, move the location of table A to from folder A to folder B, because it's expecting the fully absolute path to, like, whatever S3 folder or Hadoop folder that those files are going to be in. There is a proposal on how to fix that, so that's a temporary thing that very soon. And for most situations, it really shouldn't be an issue, like, because you shouldn't necessarily be just moving your physical files over on a regular basis. Like, that probably would not be ideal. But those
Real
are
quick, a couple call outs, because you're a little too humble to call this out yourself. Alex is actually writing a book on Iceberg, and there's an entire chapter about sort of the origins of Iceberg and how it developed out of some of the shortcomings of Hive. So check out the early access to that, because that is just raw, unfiltered thoughts from our team. And the other thing is October 10th, we will be talking about exactly what Alex just mentioned in terms of multi-table transactions with Dremio Arctic. So October 10th, stay tuned. And now back to your regularly scheduled program.
cool. And yes, so if you want to get the early copy of that book, just head over to dremio.com. The link's right there on the main page to where you can get the early access copy. But yeah, we're getting pretty close to wrapping up the first draft of the manuscript, so I'm pretty excited.
Yeah. Awesome.
How far back can you go with time travel snapshots? Is it similar to Snowflake 90 days? There is no set time period. So basically, you get to manage this. Like, there is settings you can change in the table, but at the end of the day, it's going to come down to when you decide to run expiration type procedures. So this would be a expire snapshots procedure in Spark or a vacuum procedure in Dremio. But when you run these procedures, you'll actually say, okay, I want to expire all snapshots prior to this date. Okay, and then that will be as far back as you can time travel. Now, with Dremio's table optimization, you'll also be able to set an automatic expiration where it'll say, okay, always make sure that the catalog, everything beyond 90 days, 100 days, 5 days is expired. So you'll be able to set those settings yourself. You're not married to a number that Dremio decided or any provider decided, because it's not the data is yours. The data is in your storage. We just facilitate doing those transactions on that data for you, so you get to decide, sort of what your policies are, and you have that flexibility. Okay, I think that's all the questions. Okay, but again, we have a lot of great topics coming up in the coming weeks. So next week, we're going to be doing actually more about table formats. So if you want to hear more about Iceberg, Delta Lake, Hoodie, next week we're doing the who, what, why, and what of data lakehouse table formats. So we'll talk about how each one's architected and how each one works and the pros and cons and all that stuff. Then after that, I'm going to be talking about materialized views versus Dremio data reflections. Because a lot of times people think of like data reflections, which is a Dremio feature, very similarly to materialized views, but it does so much more and offers, it's really cool. So if you want to really kind of capture the nuances of what the distinctions are, make sure you're there for that one. We're going to be doing the Arctic, when you mentioned like the multi-table transactions and zero copy clones. So we have so much great content. If you can't be here live every week, make sure to subscribe on iTunes or Spotify to Gnarly Data Waves. And then again, also subscribe to youtube.com/Dremio, where we also post the recordings of these as well. But either way, I'll see you all next week. Have a great day. Again, thank you, Jeremiah, for being here this week, as always.
Thank you, Alex.